All right, guys, we are going to be looking at this model of a divergent plate boundary. As you can see here, what we have going on here is we have the arrows indicating which direction that the two plates are going. We can see the surface of the Earth, which is all green. That's the surface here of the continent. And then underneath, you can see the crust is the gray part, which is with the green grass or whatever trees growing on top of it. And underneath, we've got the mantle in red or orange. And you've got those arrows showing the convection cells pushing outwards on the divergent boundary. Now, at this point, you don't see a divergent boundary. And why is that? Well, the reason is that, remember, at one point, South America and Africa were one plate. They were all stuck together. But eventually, those convection currents driving underneath the mantle, inside the mantle, drove those two plates to rip in half. So what we're going to do is we're going to pick a long time period, because this takes a very, very long time to happen. And we're going to watch what happens. So I'm going to pick 20 million years, and we're going to run this process. And as this happens, you're going to see some earthquakes forming in the middle. I'm going to pause that. So you should have seen those earthquakes that were forming in the middle, and that's where that boundary is going to form. And you can see this little notch right here. This little notch shows where that boundary is going to start to form. We're going to keep going. We're going to play this again. We're going to let it keep going. We see more and more of this. And all of a sudden, pause, you're going to see some indentations forming right along the middle here. So that the crust is starting to buckle, starting to get pulled apart, sort of like imagine if you had a piece of silly putty or gum or something and you were pulling it apart from each other and it started to get thin in the middle before it snapped or before it broke, you would see that it would get thin there in the middle. We'll keep going, keep playing this. And eventually it's getting thinner and thinner and thinner. And then you're going to start to see here that you've got this little tiny red line coming here. That's a little bit of that magma from the mantle sneaking up in that boundary. And it's going to start to form. You can start to see, sort of see it maybe a little bit of a volcano right there. And also you're going to see this gray strip here, and you're going to see a little bit of blue. That blue is going to become where ocean water from either side of the continent is going to rush in and fill that this sort of uh, shallow area here. It's going to start to fill into that area. And we'll play this and we'll see it happening. Again, you can see the water starting to fill in here, and you start to see volcanoes and earthquakes continuing to form, some islands even forming in the middle of the ocean. But you've got this widening ocean. So again, what happens is first we've got one continent that's together, and then over time it starts to separate apart, and you end up getting these underwater mountains here, maybe even some volcanoes that are part of the um, that even stick out of the water and become islands that are volcanic themselves. We're going to reset this. We're going to run this one more time so you can watch it without interruption. But you'll see again the convection currents pushing outwards on the inside the mantle, which are pushing apart the two sides of the continental plate and ripping it in half eventually. And then the water starts to pour in from either side, not from the top, but from either side. The ocean starts to fill in that shallow area, and then you get a widening ocean. So we've got a really narrow ocean, but it gets wider and wider and wider as those volcanoes form.